write a formula for the rational function whose graph is shown below. So here we've got several different key features. Notice that we've got the main things we want to consider are the x-intercepts and the asymptotes. We've got two vertical asymptotes and a horizontal asymptote. And of course a y-intercept if it's not at the origin. So we're going to write a rational function here. We have f of x equals, it's going to be some fraction. The first thing that you can do actually is if you have a horizontal asymptote that is not the axis, not y equals 0, that number is going to be the leading coefficient. So we'll have 2 in front since that's the horizontal asymptote. And then for this fraction, the factors of the numerator come from the x-intercepts, and the factors of the denominator come from the vertical asymptotes. So the x-intercept of 0 means that I'll have just a factor of x in the numerator. And the x-intercept of 4 means that I'll have an x minus 4 as a factor as well. Now both of those have an exponent of 1 because you can see in the graph that the graph just crosses straight through the axis at both of those points. Okay, there's no quadratic behavior, like it doesn't bounce off like that, and it doesn't like do like a cubic where it's like flattened out or anything like that. So it just crosses straight through the axis, which means the exponents on both of those are 1. And then the vertical asymptotes give us our factors in the denominator. So -3, x equals -3 means that x plus 3 will be a factor. And the x equals 2 means that we'll have an x minus 2 as a factor. And again, the exponents on those will both be 1. We know that when the behavior on either side of the asymptote is different, meaning here I see that's going up, and here I see it's going down, we know that that exponent is going to be odd. So we'll go and just leave it as a 1. And then same thing for the 2. On the left side it's going up, and on the right side it's going down. So again, different behavior on either side, meaning that that factor has an exponent that is odd, and so again, we'll leave it as 1. The other thing, now even though we know that they're going to be odd, technically they could be 1 or 3 or 5. Typically when we're doing functions like this, we're just going to leave it as 1. But another reason for that is actually that we know that with a horizontal asymptote of y equals some number other than 0, the degrees of the numerator and denominator have to be equal. So the overall degree in the numerator is 2, and on the denominator is also 2. They have to be equal. So that's another reason that the exponents are both 1.